In our second lesson on specifically dedicated to coding in R, we're starting this section where we're looking now more at R from the perspective of storing data, indexing, extracting. So it's all about handling data, whereas yesterday was more a case of defining functions, looking up queries. Let's get started. We often wish to examine part of a data set. Suppose that our data is stored in the matrix A, and we can go right into R. How do we create a matrix? Type matrix. You need to give it the entries. So, for example, I could tell it 1 to 25. Many ways of doing that. You could say sequence from 1 to 25 and give it a length of 25. Does this work? Not the way I wanted it to. The shortcut is 1:25. So 1:25 is just this vector from 1 to 25, moving in single integer increments by row. So we give it 5 rows. N col, number of columns, 5. And you could choose to fill row by row. So in this case, it would be by row is true. The default is false. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc., etc. And let's say I want to pick out one specific entry. We could save this as, for example, my matrix or matrix A, which is, I think, what the book is doing in their example. You could ask R, what is A? That's class A. It's a matrix. Not entirely sure how to interpret that. It's a matrix and an array. Don't ask me what the difference is between them. Probably for all intents and purposes, there's probably quite a bit of overlap between those two kind of objects. So apparently when you run the matrix function, it's creating something that's both a matrix and an array, possibly, big question mark over there from my end. What if I want, let's see, what if I tried extracting the leading diagonal, 1, 7, 13, 19, 25? Is there a smart way of doing that? Well, I would approach it by running a loop. And before doing that, let's just take them individually. So 1, 1, 1, 1, that's 1. Then 2, that's 7. I'm taking the leading diagonal. And it should be pretty obvious. What we need is that we take 1, we take 2, we take 3, we take 1, 1, 2, 2, 3, 3. So what if we created a loop? First time that we're discussing such a concept, you would type 4. And if I tab, it's going to give me the overall structure. So what does it need? It needs me to label the variable and think of this as a dummy variable. It has no relation to anything else that we've defined. And I could call it, for example, K or I or J. So K will take from 1 to 5. And now we'll say, I want K comma K. So it's going to do this 5 times since I've taken K as each entry of this vector, AKK. Now, we're going to create a new vector with the diagonal entries. So let's say Z. Let's say save each diagonal entry in Z and create. You could create a null vector initially. So diag entries, just create a null vector. So this is an empty vector, no entries. So if I call it, you just have null displayed in the console. Now we could say your diag. I'm just going to mute everyone's mic. Of course, if you have questions, do let me know, but otherwise we'll get a lot of background noise. Diag entries. I'm going to save each time, each diagonal entry, the 1, the 7, the 13, the 19, until the 25. I'm going to save it in diag entries, meaning for each run of this loop, this vector, its length will increase by 1. And I can just say, I think C would work. C concatenate the original diag entries and Z. So let's see if we're following the logic. You create what is initially an empty bucket with the intention to fill it with the 5 diagonal entries. We then move on to the repetitive part, which is why we're creating a loop. And I've done that by simply typing 4, taking a random variable. I really should not be calling it a random variable, right? I picked a letter at random. It probably doesn't even need to be a letter. You could be even. I wouldn't be surprised if it works for a string as well. From 1 to 5. So this is going to run it 5 times. When k is 1, it will take A11, which happens to be this first entry, save it in Z, but then we will redefine diag entries by concatenating its current form with the newly extracted data value. And let's see. And we can do print. At the end, we can do print diag entries. Let's run it. And there we go. Exactly what we were after. So loop is basically, I'm reading the chat, a bunch of nested entries into each other. You might want to specify. Would you like to ask out loud? I don't know if you're available right now.
I see it. Because I'm actually in a restaurant.
That's fine. I'll try my best to answer it. To answer your question, if
yes, of course.
maybe you can't.
I was just basically asking if the loop is basically it's like not a summarized version I wanted to say, but almost it contains some nested stuff in it.
You could have a loop within a loop.
Yeah, exactly.
Although over here, I would just, you might. This is an extremely simple example.
Yeah.
I would just describe it as it's doing something 5 times.
And could you, for example, is there some sort of code or whatever just to specify from your entries just the odd numbers and just the even numbers? Because the first thought that came in mind that the numbers are all odd. So the first thing I would have done is to, like, from those entries that you had, just pick the odd and then disseminate into just that diagonal.
Yeah, I see where you're coming from. It is the case, I agree, that these are odd numbers. I think I can even go a step further. I think there's a pattern, right? You're adding 6 each time. But the way we're writing the code, doesn't really depend on the values that it's going to extract ultimately. It really, it depends on the indexing. All it's doing, all that it's doing, these could have been string, it could have been character entries. So in that case, odd and even wouldn't even apply. I would think of this, to summarize, and thank you for your question. To summarize, we are simply repeating an action 5 times. It saved me the trouble of having to manually type it more than once, specifically from 1 to 5. And I decided I could have decided to take just a column. I could have done so I could have taken, for example, all the entries in the 4th column. Let's see if this works. So 4th column, 4, 9, 14, 19, 24, 4, 9, 14, 19, 24. Right, so hopefully this gives you an idea how you can select one or multiple entries in a matrix. They're using a 4x4 over here. Doesn't really change our discussion. The first number after the open bracket symbol always refers to the row, and second number is always the column. You may know this as Roman Catholic, row, column. It's quite a standard convention, although confusingly Excel, at least not in VBA, and don't even ask me what the convention is in VBA. It's been so many years since I last wrote any code over there. But confusingly in Excel, if you have cell A1, A is the column and 1 is the row, which it's a real pity, isn't it? We can also select multiple rows and columns at a time by providing vectors as indices. So let's have a look. We're saying matrix A, and we want, not entirely sure I'm following, 1, 3 and 2, 4. I'm stuck. So it's picking out 5, 13, 7, 7, 15. 5, 13, 7, 15. Why is it doing that? 1, 3, 1. Oh, right. So it's picking, and I'm seeing another comment in the chat. Yes, I've heard of these pipes, although I've only come across them in videos. We'll put that down on our to-do list. I don't know much about pipes. I know they are a thing, but that's it really. So let's see. So we're saying column, excuse me, rows 1, 3, rows 1, 3, and columns 2, 4. And where you get overlap, that's going to be your matrix. 5, 7, 13, 15. 5, 7, 13, 15. You could do something similar without skipping any rows. Over here we skip the 2nd row. Over here we skip the 3rd row. You could include them by just telling R, this matrix, I want the first 3 rows overlapping with the columns from column 2 to column 4. If you don't specify the column, for instance, over here, it's going to take all the columns. Meaning, if you go back and we clear everything, and this is our matrix A, if I only want the last column, for instance, then I will say I want every row, so I don't specify any rows, comma. And then I say the fifth column, and that's 5, 10, 15. You have your multiples of 5, just the way we've set this matrix up. The last two examples include either no index for the columns or no index for the rows. These indicate that R should include all columns or rows, respectively. R treats a single row or column of a matrix as a vector, which is similar to what we've just done over here. Now, the negative sign, notice the negative over here. To my knowledge, this is negation. This means take everything with the exception of what follows the negative. So let's say, I wonder if this works. And there's this idea of trying to anticipate what the code is going to give you. Would this, if I had to run line 4, would we get the entire matrix with the exception of the fifth column? Let's have a look. That seems to have worked. So placing a negative, we're not referring to column -5. There's no such thing as column -5. However, in this context, the negative is interpreted as negation, so excluding, right? So now we're saying negate. I guess we need to go back to column A. Anyway, never mind. The dimension function outputs the number of rows followed by the number of columns of a given matrix. Let's go back over here. Why don't we create a different one? Why don't we create, for instance, say this over here. This over there. You could square root each entry. The really great thing is that it's so simple. So square rooted each entry. You could define this as matrix B. I'm just playing around over here. If we do dimension B, so that's a 5 by 6, and as always, 5 rows, 6 columns. Loading data. For most analyses, the first step involves importing a dataset into R. The read table function is one of the primary ways to do this. The help file contains details about how to use this function. We can use the function write table to export. So this is going in both directions. Before attempting to load a dataset, we must make sure that R knows to search for the data in the proper directory. So this saves you the hassle of having to type out the entire directory, C:/, etc. For example, on the Windows system, one could select the directory using change dir option under the file menu. However, the details of how to do this depend on the operating system that is being used, and so we do not give further details here. We begin by loading in the auto dataset. This data is part of the ISLR library. But to illustrate the read table function, we load it now from a text file. So this is just all the different ways that you can, from where or how you can place the data in your working environment. You can actually download this text file. We could do it right now if you like. The text file can be obtained from this book's website. So you would download it. And where did they mention the website? Is it? It's not this, is it? This is just the general repository. I might skip this step if it's all the same. I just might extract it from the library. So let's see. Let's delete everything. and we're going to, I really don't know what word to use over here. I'm gonna tell R, please use this library. And this library contains data sets. In fact, if we go in the help file, which didn't work, I think we're gonna have to look it up over here. There are these different data sets, and specifically, I think the chapter is using auto. So let's see. They're doing it from a text file. So they are defining a variable, auto. Think of this as the usual arrow. Read table. And notice they haven't specified the entire file path, for the simple reason that they're probably, they've probably already specified where this data is saved. We'll do it, we'll just load it like this. Data, auto, let's save it as something, let's save it as auto. Or has that not worked? Okay, no. You don't do it like that. You don't do it like that. Once you're on data, huh. I wonder what this is, promise. Let's clear everything and let's see if we're doing it. Interesting. So if I run, well, that seems to have worked. Okay. So this is the data set. If you click this over here, you can view it. You can view everything. Now you might ask, for example, how many observations does it contain? Well, to do this, you could just ask how many rows, number of rows in auto 392. Of course, that's really unnecessary, isn't it? Because the environment, unless you want to save it, perhaps you're going to calculate the mean. So at some point you might want to divide by 392 to take a straightforward example. We're told over here 392 observations, and there are nine variables. We can type str, and this has transposed the data. So each line is a specific field, it's a specific variable. And for instance, later on, we may use the, who knows, we may use the horsepower and the weight to predict the acceleration, right? If we go back to the regression that we've been discussing. Okay. Look, we're using the same syntax as with matrices. So what should this give us? What should give us the first 4 rows, correct? Let's have a look. Auto, 1 to 4. And there you go. First 4, 1, 2, 3, 4, 1, 2, 3, 4, from MPG to your, and including these last 2 variables, origin and name. Notice, since it's a data frame, you can have different types of data. Most of it is numerical, but the last column contains string. String data. Let's continue. Once the data are loaded correctly, we can use names to check the variable names. So relatively straightforward. Names like that. Those are your names. You could save them as a vector. You could even change the names. Let's move on to additional graphical and numerical summaries. We can use the plot function, as we did yesterday, to produce scatter plots of the quantitative variables. However, simply typing the variable names will produce an error message because R does not know that it needs to look in the auto dataset. So if I say plot and I want to take the weight, there is a way around this where this specific line of code, exactly what I've typed, would actually work. So this is an error. This is going to give you an error. Now what you need to do, just before we read on, is you need to tell R it is this column of values in the auto dataset against these values in the MPG field. This should work now. This should work. And hopefully we're already thinking about correlation, curve fitting. You may, for example, think that linear regression might do quite a good job, at least for regions of this plot. And let's see how the book tackles it. To my knowledge, there's a way where you can sort of fix a data set, although I think best practices typically recommend against. Let's see. So we get an error. And in fact, they've done it the way we have in this line. The word is attach. If you run this line of code, attach auto, then you can omit auto dollar and auto dollar. Alternatively, we may use the attach function in order to tell R to make the variables in this data frame available by name. I wonder if there's a warning that it's not necessarily always such a good idea. The cylinders variable is stored as a numeric vector, so R has treated it as quantitative. However, since there are only a small number of possible values for cylinders, one may prefer to treat it as a qualitative variable. So let's have a look at cylinders against MPG. Oh, you can tab, by the way. So if you know that you're looking in auto, once you do $sign, I think it's automatic, but even if I go somewhere else, once my cursor is placed right after the dollar, tab brings up the entire list of potential column names. And we wanted cylinders, correct? Which is like this. And although it is quantitative, so there are cars with 3 cylinders up to 8 cylinder, you may wish to treat it as what we call, and I think it's the first time we're mentioning this type of object. It's called a factor. The as factor function converts quantitative variables into qualitative variables. Okay. Now, all the written code, I think is assuming that we've attached. So we'll probably attach as well. Yeah, let's do it right now. Attach. And now this means that if I type cylinders, I'm going to, R knows that it needs to look into auto. So we now have in the console, it's displaying each data value for the cylinders data. We can plot cylinders against MPG, and each line is adding, we're sort of embellishing the plot. So we're choosing a color. I wonder what this is. Looks like variable width is true. Oh, incidentally, in R, you don't need to type true. You could just type T. And the same applies for false with the first initial. Horizontal is equal to T. Why don't we run these lines and see the changes each time? So I'll attach, interesting. Is it because I cleared everything? Okay, so what's the problem here? Because maybe because it's already attached. Okay, okay, so we don't need to run attach again. Let's plot. Cylinders against MPG. Now we'll specify color is red. Incidentally, there is a way of, I think, changing the shade. What if I do red 50? No, that's there. But there's definitely a way. I don't know, maybe, but I mean, there is some way where you can sort of, for example, if it's black, you get different shades of gray. Now, what does var width do? Var? It's interesting, this doesn't even come up as an option. And we say true. Well, it just hasn't worked, has it? Maybe it's T. And there were 18 warnings. Okay, so that hasn't worked. Let's see horizontal. And that hasn't worked either. The hist function can be used to plot a histogram. We've been using this over and over. Note that column equals 2 as color, excuse me, color equals 2 has the same effect as color red. So let's take a histogram. We're going to look at the shape of the data. Is one way of describing it. That's your histogram. And we have red. And also breaks is equal to 15. Does this change the width of each column? It does. It does. In fact, there was a session recently where I was trying to do exactly this. And what we needed was breaks. Breaks is equal to 15. In this case, we're taking, I would imagine, or is it saying 15 buckets? 1, 2, 3, 4, 5, 6, 7, 8, 9. No, neither, right? I think there's more than 15 of them. Let's see what the book has to say. Doesn't seem to say anything. So what if we change breaks to 2? Right. So there might be some executive power from R where perhaps it takes the 2 more as a guide than anything else. It definitely seems to be influencing the number of columns. if not exactly as I was expecting, definitely close enough. And if we take 100, okay. So it might not necessarily be exactly 100. There might be some adjustment. And sometimes that adjustment will coincide perfectly with what you've specified. Again, all these adjustments, usually everything that's kind of being done by R can usually be is the word I'm looking for, bypassed, right? You can manually override it. The pairs function creates a scatter plot matrix. Ah, interesting. i.e. a scatter plot for every pair of variables for any given data set. Okay, this is going to be interesting. So pairs. So try anticipating what we're going to get. We're going to get a scatter plot for every pair of variables. Remember what are our variables? Names, auto, and we have 9 of them. So I wonder what it does if you have qualitative data, such as the last column. Let's have a look. And it's probably running it. Yes, it has 4 names as well. Although what it's doing, it's probably taking each name as a unique, if there isn't any repetition, might be taking it as a unique. Nah, I have no idea. I have no idea. What I do know is that if I pick any one of these at random, let's use color pink. So let's take this one, for instance. What are we plotting over there? Well, it's in the acceleration column and in the horsepower column. So that is it's horsepower against acceleration. Now, if you only want a subset, apparently this is what you type: pairs, and then tilde, take the 5 or however many columns or variables, and then you need to specify auto. So let's see, pairs, tilde, don't ask me why. And we'll say, for example, we could take just 3. Okay, what am I missing? Inverted commas? No. Okay, it doesn't want names, does it? In fact. So what about your? It's a bit more manageable, isn't it? We're taking 3 variables now as opposed to the full set of data. Maybe I shouldn't have said full set of data, maybe the full extent of the data. Let's make it clear. You are taking each data subject. So how many dots do we have? Well, we have 392. That's the number of observations that we're working with. That's the number of rows in our data set. By the way, if you want the last 10 rows of data, head auto 10, and that's 10 of them. I need to scroll up to see everything. MPG cylinders until names. These would be types of cars, I'd imagine. You have your Buicks, your Chevrolets. If you want only one specific row of data, then it is auto. If I say 900, that's an error. There is no such thing as the 900th observation, the 900th data subject. It should work if I type 200. Oh, well, of course, because I think I'm missing a comma, right? The 200th row, all columns. If I only want column 3 to 6, now we have only displacement, horsepower, weight, and acceleration. In conjunction with the plot function, identify provides a useful interactive method for identifying the value for a particular variable for points on a plot. I'm lost. We pass in 3 arguments to identify the x-axis variable, the y-axis variable, and the variable whose values we would like to see printed for each point. So I'm finding this very hard to follow. Then clicking on a given point in the plot will cause R to print the value of the variable of interest. Right-clicking on the plot will exit the identify function. Let's see. Is it going to make it interactive? Of course. So we have this. That's our scatter plot. Identify again for horsepower mpg, miles per gallon, I'd imagine. And then name. Okay. Let's see. Interesting. It seems to be doing something, but don't ask me. I don't know if you're seeing it, but there's like a bubble coming out. What's it meant to do again? The numbers printed under the identify function. Is it doing anything? Am I missing it? We'll just have to continue. I shouldn't say it's probably not that important, but I don't think it's that important. It's a pity that we're not getting it to work. But I think it's time to continue. The summary function produces a numerical summary of each variable in a particular data set. We've often done this. If it's numerical data, it will give you the quartiles as well as the mean. If it's qualitative, it will give you like a frequency table. So there are 5 AMC Matadors, there are 5 Ford Pintos, etc., etc. Yeah. You can also create just a summary of a single vector. Did I say vector? It is a vector, but of a single column of your data, of a single variable. So for instance, summary Hmm. One second. Why hasn't it produced anything? Let's clear everything. Nah, I'm not liking this. I think something's going wrong. Location active, escape to finish. Oh, I see. Interesting. Wait. Is that why it wasn't working earlier? Let's just plot these two again. And if I now select this point, and this point, now I press escape. 129, 300, and 389. Are those the observations that I happen to pick over here? I think so. I think so. Oh, I see. And when it printed these, I had selected however many there are. Right. Okay, so that's why it wasn't working earlier, because I hadn't pressed escape. So that's how you'd use the identify function. If you want to identify a specific, let's do another one now that we've got it working. So it's interesting for outliers, isn't it? So let's say acceleration and weight. Now, in terms of outliers, you would say you'd identify like maybe a general trend. So like this. And this looks like an outlier to my eyes. You may consider it an outlier. It's quite a subjective term, isn't it? Or maybe better yet, this one. So let's see if we can get it to work. We'll run the function identify acceleration weight. And look, it's still running. See the stop? That means it's compiling. And it's going to continue that way until we press escape. In many ways, it's expecting, it's waiting for us to give our next input. And our next input could be selecting this point. Okay, I've selected it. Maybe I want to select this one as well. And perhaps this one. So that's 3 of them. Now I press escape. And you'd probably want to look them up in your data set. So auto, concatenate, the 12th row, the 29th row, and the 202 row, and either all columns or who knows, just the accelerate. Let's just do all columns. And it's these 3 where they kind of, oh look, let's even label them now. I guess that was probably right after I pressed escape. Why are these outliers? And that would be maybe you might be able to spot something within these numbers. What are we plotting? The weight against the acceleration. So for example, 202, it has a very low weight, but even the acceleration is low. 202. Why has it produced 204 if I ask for 202? That's odd, isn't it? Because 12 and 29, how very strange. How very strange. Maybe there's no such, if we look at the data, I mean, we are going to find 202, aren't we? I'd be very surprised. And yet it's giving 204. Now that's really odd, isn't it? Something is off. What if I do auto 202 with a comma, of course? That's weird. So what if I ask it for 204? And that's it. Okay, so it seems to be offset by 2 for whatever reason. But the funny thing is that when we asked for 12 and 29, it didn't give 14 and 31. So I'm not entirely sure what's going on over here. Anyway, we'll have to never mind. Let's continue. Once we have finished R, we can. So this is the end of the section. If we're discussing Q. Oh look, save history. Load history. Let's see what comes up. Hasn't produced anything, has it? Great. Now we've arrived to the exercises. And how are we doing for time? Yeah, we could do a few more minutes. Just enough time to perhaps discuss. Probably makes little sense giving away the answers, assuming I even know them. So we have how many pages of exercises? 1, 2, 3, 4, 5, 6. 6 of them, right? And the section appears to be divided into conceptual, where there aren't any specific numbers or data sets. For example, I guess, are these true or false? For each of parts A through D, indicate whether we would generally expect the performance of a flexible statistical learning method to be better or worse than an inflexible method. Justify your answer. These exercises are great because they kind of force you to go back and look up exactly what we mean by flexible and inflexible, as well as just how we're rating the performance of a learning method. So, for example, the relationship between the predictors and response is highly nonlinear. Should be cool, and that one's quite obvious how to answer it. Explain whether each scenario is a classification or regression problem. Again, it's really compelling you to see that you feel comfortable distinguishing between the two types of models discussed in this book. Remember, classifying is where you're grouping. You're not working with numerical outputs. You're trying to, the examples we took 2 or 3 sessions ago, it was a binary type output, political party A against political party B, and no other parties. And regression is when what you're predicting is numerical. It is continuous, usually continuous data. Provide n and p. Well, you know what n is. I wonder if we remember what p is. P is the number of variables that you're going to that you're going to have your model look at, and that ultimately your model will use to make predictions. So look, I mean, as soon as you see, we wish to know whether it will be a success or a failure. It's pretty obvious, right? Bias variance, decomposition. I think this is where maybe we struggled a little bit. Real life applications. This is the k nearest neighbors. This would be fun. This would be fun. Compute the distance between each observation, and so the test point is 0, 0, 0. So you have four. This is your data set. It's 6 observations. You have the variables that you're going to use to predict, known as the predictor variables, and the variable that you're going to try predicting, usually denoted by y. Beyond this, we're going to consider a 7th data subject. It's what the book normally refers to as x naught and y naught. And these are all going to be 0, 0, 0, and 0. And we need to predict, I guess it's between green or red in this case. Afterwards, we'll have an exercise on, I should probably assign these. What we'll do is, perhaps if we're meeting tomorrow, just these usual sessions I'm referring to, we could actually start chapter 3, and maybe we say, for example, 2 weeks. I'd like to avoid any deadlines which don't necessarily give everyone the opportunity to make time to actually attempt them themselves. So each data subject is a college, right? A college or a university. Fascinating. So, oh wow, are we going to predict the graduation rate? Looks like fun, doesn't it? Do we do any predictions on this data set? So we have exercises 8 and 9. Each one is on a specific data set within the package. So you will have to install the package that is associated with this book. And you would do that, as always. You could either type library ISLR, but you first have to install it. The way you would install it, you could either type install packages ISLR, that should work. Or else you go into packages over here, install, type it, ISLR, and once you've selected it, now interesting is ISLR2. They might be related, who knows? Maybe it's related to the 2nd edition, but I think we are using the 2nd. Not necessarily. Look, so we're going to exclude the first column, for instance, over here. So that would that would be a case of excluding the private variable if a college is public or private. In our next session, and there might be time to do one tomorrow, in our next session, this is where things are going to get, I would imagine, more theoretical and more technical, and we'll start linear regression. And the great thing about this book is that there isn't going to be, I'd be surprised if there's going to be material or ideas that are going to be particularly new. Now that we've covered chapter 2, especially once we tackle the exercises, we're probably not going to find this too challenging. Yeah, I mean, there are these formulae, but it's not too difficult. And we'll end it over here.